This is a short video about Matlab, trying to demonstrate its capabilities and how it can be used in this course, but also I think you'll find it useful beyond just the confines of this course and actual practice as an engineer or in future courses. You can see I'm running Matlab because of what it says at the top of this title bar over here on the right side. That's the command window for Matlab. There is a public domain version of Matlab which is known as Octave, and you can see the Octave can be obtained at the GNU website. You can download your own copy of Octave for free. It supports lots of different systems. I happen to be running on a Macintosh, and that's the one I would download if I were using it. The Matlab command window is here over on the right side. The really interesting thing about Matlab is I don't have to write a standalone program and then run it. I can do a lot just typing commands to Matlab at the keyboard, and that's what I'm going to primarily show today. Over here on the left side is a figure window, a plot window, and that's where all my plots are going to show up. And I think you'll finally see why we're so enthusiastic about using Matlab, especially for this course. So every variable in Matlab is a vector, or more generally a matrix. And this is extremely useful, as I want to show you. So let me define a vector, a x, and I'm going to say that's equal to 0:10. And so this this command says set the variable x equal to a row vector whose elements start at 0, increment by 1, going from element to element in the vector, and wind up with a value of 10. And if you just hit return, you'll see that x has been defined to be that variable, and sure enough, it's a vector of 11 elements consisting of the integers 0 through 10. Well, I can plot this against itself. It's not a very interesting plot, but I can do it. And the plot command in Matlab is plot. This is what I would plot on the x-axis. You can see the little help window that pops up in Matlab. That won't pop up in Octave, but you really don't need it to do your work. And I'm going to plot that against itself. And the plot on the left side won't change much because that's what I was setting up before. And you can see that it's plotted a straight line as you would expect. Well, I can plot x to, and instead I'll make the vertical scale 5 times x. So the usual syntax for doing multiplication, division, addition, and everything still apply to variables in Matlab. Now I'm going to do something a bit fancier. I'm going to plot x 5 times x plus 2. The reason that's fancy is what is going to happen when I add this is a vector, 5 times x is a vector, but 2 is a scalar. And what does Matlab do? Well, it does the thing you want it to do. It's going to add 2 to every element of 5 times x. And so when I finally plot this, you see the plot changes, and there's an offset by 2 at the origin. So a vector plus a scalar is a vector with the scalar added to every element of the vector. Same for subtraction, etc. Now, suppose I wanted to plot y equals x squared. Well, first of all, what is this mean? Well, you cannot multiply a vector times a vector. It doesn't work. And it's going to complain because it basically is assuming everything is a matrix multiplication. All the matrix multiplication rules apply. But Matlab has a very special syntax for term by term multiplication. So what this, see that dot in front of the star? What that means, instead of thinking about x as a vector and just doing vector times vector multiplication. This means do term by term multiplication. So since x consists of the integers 0 to 10, the y vector here should consist of the squares of every element. And that's exactly what they are. And so this dot star is what you need if you want to apply the same mathematical operation to every element of a vector. And now I can plot y versus x, and I get a parabola, as you would expect. So let me label the axes. I always like to do that. You label the x-axis with the command xlabel, and you enclose strings in Matlab with single quotes, not double quotes, it turns out, single quotes, and there will pop up a label over here in the plot window, and I'll do one for the y-axis. Not going to do anything fancy, just call it y. And you can see it actually rotates it counterclockwise, so it looks pretty. Well, you certainly, if you do something like what is sine of 2 times pi times x over 5. So pi is defined. It's already predefined for you. And I think this makes perfect sense. Well, what does sine of a vector mean? Well, all the special functions in Matlab are set up so that if you type this, what this means is term by term application of this function to the vector x. And so what we get back is, you can see now the values are equal to sine of 2 pi times the integers 0 to 10 divided by 5. It's not a very exciting result, but there it is. Well, you can see that what Matlab does is that after a calculation like this sine, it gives you an answer, and it's going to tell you that. Well, you may not want to see every detail of every calculation. So what you can do is you type it in. If you end the line with a semicolon, nothing gets typed at you, but the calculations are still performed. Notice it just performed the calculations, but it did not type them out for you. So I'm going to, from now on, use the semicolon because I don't want to see all the intermediate calculations. Now there's another very cool thing that saves typing. Remember, use MATLAB a lot at the command line, not necessarily to write a program for. I'm going to type SIN, and you can't see it, but I'm going to type an up arrow on my keyboard, and it's going to bring up the previous command that began with SIN. I'm going to go over here and say y equals, and hit return. And now the variable y, if I just type it, I can see its values. You can see it is stored all the values of this previous calculation that I did before. And I can plot it. So I'm going to bring up the plot command. I type PL up arrow, and there it is. And it doesn't look much like a sine wave, but I can fix that. So I'm going to redefine x. I'm going to say x, and I'm just going to go up arrow. There's the x label, hit up arrow again, and there's my definition for x. I'm going to add an argument here, 0.01 colon. So if you have an intermediate value in the colon notation here, now the increment, instead of being 1 between the elements of the vector, now it's going to be 0.01. And I don't really want to show you all those, so I'm going to type a semicolon out there, and there's x. I'm going to recalculate the sine function. So I'm going to be over the same interval, but now much more finely represented, and the plot command gives me something that looks very much like a sine. So now you can see that you can really do some very simple calculations or complicated calculations at the keyboard, getting plots and seeing what they look like. Now I want to show you something else that's going to be very important. Suppose I want to plot 1 over x. So let's define y equals to 1 / x. Do you think this is going to work? And 1 is a scalar. Don't forget that x is a vector. And a scalar divided by a vector doesn't work very well, and you get that same command again. Guess what you type to fix this? If I just hit an up arrow now, it's just going to bring up the previous line, and I'm going to go over, type my dot like I should have, and I'm going to put a semicolon out here because I certainly don't want to see all these values of y here. Let's see, there's 0.01 times 10, so there's 1,000 elements there, and I don't really want to see them all, so I'll do that. And now I'll bring up my plot command, and there it is. It looks like a hyperbola. Well, those of you who know what I follow what I just did know that y of 1 is 1 over 0. And guess what Matlab says it is? It is indeed infinity. So the way to access any element of a vector is you give the name of the vector, and in parentheses you put the element you want to extract. If I wanted to extract the first 10 elements, guess what I'd use? I'd use the colon notation again. This time always, since it's trying to index y, it always starts, the increments should be 1, so 1 colon 10 will work fine. And in Matlab, all indexes for array start at 1, not 0 like they do in C. So this gives me the first 10 elements. These should be 1 over x, going along in a very fine way, detailed way. You can say it has explicitly knows infinity, and 1 over 0.01 is 100, etc. So the plot command is smart enough that if it sees infinity, it doesn't plot it at all. So that's why this plot, the vertical scale here, starts at 100. And by the way, all plots are auto-scaled. It's going to find the scale that makes things fit. And you can change those if you look at the details of how the plot command works. So the getting help is easy for a given command like plot. How do I change the axes, things like that? You type help plot, and you will get something you can see it's got lots and lots of detail here, which you should go through when you're first getting started with Matlab. Now, suppose I want to try something. I want to calculate something that looks like, let's say, x squared divided by sine of x. So y equals x dot up arrow 2. I think you now know what the dot means. That means I'm going to take the vector x and term by term compute the square. I'm going to divide that by sine of x, which is kind of a silly thing, but I'm going to do it anyway. And notice I have to do the dot again. So it's dot slash, and I don't want to have it all typed out at me. And so let's see what y is, the first 10 elements. And you can see that at x equals 0, we get 0 divided by 0, and Matlab has said that's not a number. Nan means not a number. And so Matlab can take care of these calculations. It doesn't care if things go to infinity. If you divide 0 by 0, it's still going to return an answer. And that's one of the very interesting things about Matlab. So plot, I can plot these two things, and it looks kind of screwy at the places where the sine function is going to 0. You can see it's kind of start to blow up, but the plot still's there. Okay, so this is how you divide a vector by another vector. You use the dot slash notation. Now, the other interesting thing about Matlab is that it loves complex numbers. It doesn't care. So if you type square root of -2, it's going to tell you that that is 0 plus 1.4142 times I. They use I for the square root of minus 1. I can't change it to j. However, what's also very interesting about Matlab is that the variable I is predefined, in this case, to be 28 because I'd written a program before. If I say I equals the square root of minus 1, that turns out to be the default. When you first run Matlab, that's going to be the default value. There's a special symbol that they use, because you see what happened to me. I ran a program before where I used I as an index, and I, being the square root of minus 1, got redefined by my program. There's a special symbol, 1i, which is an illegal variable name, but it's reserved in Matlab to be the square root of minus 1. And also 1j is defined, which is also the square root of minus 1. So I would tend to use 1j. So I'm going to define y to be equal to the exponent of 1j times 2 times pi times a vector f, which I'm going to say runs from 0 to point in terms steps of 101 to 2, let's say. And notice I didn't have to define the immediate variable. I can just type this vector inside and everything's going to work fine. So I do that. And if I did plot y is complex, and what it's going to do is plot the imaginary part versus the real part, and that's a circle. So I can also plot the real part of y, which is a cosine. And notice I did not give it an x argument. What it's doing is just plotting it against the index into the vector. And this is a way of getting plots going very quickly, not worrying about the details of a plot when you're trying to debug or get something just to work. And of course you can do the imaginary part. And there's the sine wave that's coming out of the complex exponential. But notice, the thing I want to emphasize is it did calculations with complex numbers just like they were real numbers. It really doesn't care. So this is very handy for us because here's our complex exponential signal. We use that a lot in this course, and it's very easy to type it in and use it just like it was a real variable that you would in most other programming languages. So I think you can see why Matlab is so useful. Play with it, learn its commands, and one other thing before I leave is I want to show you how to write a loop. So the for command exists in Matlab, and I'm just going to say I equals 1:10, and I think I forgot the equals 1:10. And I think you know what it's going to do. It's a loop. It's going to start with I equal to 1 and wind up at a value of 10, incrementing by 1 every time. And I'm going to say that z of I is equal to I up arrow 2. So I'm going to put in the squares. It's kind of a silly program. And then the way the for loop is terminated is with the end statement. And it has set up a vector z, which is going to have 10 elements equal to the squares. Fine. I could have done this much more simply. I say for x equals 1:10 does exactly the same thing, except I didn't square it. And now if I do x dot up arrow 2, now I get the same thing as z. And I could have either written a loop or I could have used the special notation in Matlab. And I think it's pretty clear that writing the loop is not that great a deal. Now, suppose I wanted to find the average of the x's. Okay, there's a special command that'll do that called sum, and that will sum it all up, and you can divide by the length of x, and I think it's pretty clear what the length is going to do, and that's the average of the squares of the first 10 integers. You can also do some other very important things like this that are matrix-like things. There's a mean function which will do exactly the same thing as what I just typed, and of course it gives exactly the same answer. There are many, many built-in functions ready for you to use. You just have to go in there and explore Matlab and find out what they are. There's many, many tutorials online for helping you on getting into Matlab and get started. But I think you can see why we use it a lot, and you will be asked to use it to work some of the homework problems because I need some numeric answers occasionally. Hope you enjoy using Matlab in this course and later on.